Example 1. Solve the equation 2x squared minus 5x plus 3 equals 0 using the quadratic formula. Now, one of the only conditions when you're using the quadratic formula is that your equation must equal 0. Okay, so if you're going to use the quadratic formula, you have an a value, you have a b value, you have a c value, but the equation must equal 0 first. Then we make a list, a, b, c. Your a value is the coefficient on your x squared term, so 2. Your b value is the coefficient on your x term, so -5, and your c value is your constant, so 3. We're solving for x, so x equals. The quadratic formula says the opposite of b. So if b is -5, it's going to be a +5 when I substitute it into my quadratic formula. So the opposite of b plus or minus the square root of b in parentheses squared minus 4 times a times c, and that's all under the square root, over 2 times a. Now, when I do this, I'm going to do it step by step. So we're going to have x equals 5 plus or minus the square root, which I'm going to make a little shorter, and I'm going to grab my calculator. In my calculator, I'm going to put in parentheses -5 squared minus 4 times 2 times 3, which is going to get me 1. All over 2 times 2, which is 4. Then I'm going to look at the square root of 1. I'm going to ask myself if that comes out nicely, because sometimes it will not, but this does, which is 1. So I'm going to have two separate equations. X equals 5 plus the square root of 1, which is 1, over 4. And my other equation is x equals 5. And then remember this plus or minus. So this time I'm going to do the minus square root of 1, which is 1 over 4. My first one, I'm going to take 5 plus 1, which is 6 over 4, which simplifies to 3 halves. So x equals 3 halves is our first solution. The second one, we're going to take 5 minus 1, which is 4 over 4, which simplifies to 1. So x equals 1. And those are our two solutions. If we were to have graphed this, 2x squared minus 5x plus 3, those would be our two x-intercepts.